So the goal of this lab on ranking oxidization agents is to rank 4 metals from the strongest to the weakest oxidizing agent. In other words, to rank the metals from best at taking electrons from others to worst at taking electrons. We're going to be ranking the metals copper, zinc, lead, and magnesium. So ultimately what you should be able to do is to take each of the different metals and then place it in a sequence compared to the others. So you might decide that lead was the second weakest and that magnesium was the strongest, for example. All right, so what does it exactly mean to be an oxidizing agent, or for that matter, a reducing agent? So the oxidizing agent in a reaction is the element that takes an electron, or perhaps several electrons, from another element. When an element loses electrons, it's said to be oxidized. And if you think about it, oxygen, which is usually neutral, often winds up in a charged state of 2- because it takes electrons from other things. So we're kind of broadening the idea of what oxygen does, stealing electrons and applying it to other things and calling that oxidization. So the charge of the element which does the oxidizing is reduced. So oxygen goes from 0 to -2. And so the element is said to have been reduced. Its charge goes down. In a reaction, elements that are reduced act as agents to oxidize other agents. Elements which are oxidized act as agents to reduce other elements. So the interesting thing, though, is that an element can act as an oxidizing agent in one situation and a reducing agent in the other. In other words, it can be reduced in one situation and oxidized in another. To try to understand this, let's take a look at what happens to magnesium in two different reactions. Okay, so let's start off and look at the top reaction here. Now, if you look at magnesium, it's reacting with copper. And by the way, magnesium was probably part of some salt, so there's probably a negative ion floating around in the solution that we don't really care about. It's not going to react with anything, and ions like that are usually referred to as spectator ions. In any case, in the first reaction, the magnesium, which has a charge of +2, is stealing electrons away from calcium, which is originally neutral, so that calcium, after losing 2 electrons, has a charge of +2, and the magnesium, which was +2, having taken in 2 minus charges, is now neutral. Okay, so here, magnesium was the oxidizing agent. It's basically doing what oxygen does, stealing electrons, 2 of them in this case, from calcium. And magnesium winds up having been reduced. Its charge state goes from +2 to 0. On the flip side, calcium has been oxidized. It has lost electrons, just like if oxygen attacked it and stole electrons from it. So it has gone from its starting state of neutral, and it's had 2 electrons taken away from it, so that it winds up in a state of +2. Now, the interesting thing is, depending upon what magnesium is reacting with, it can either be the oxidizing agent, or it can be the thing that's being oxidized. So to understand this, let's take a look at what happens in the second reaction, where magnesium and iron are reacting. Now here, what's happening is iron is starting off with a charge of +2. And that means it's just itching to steal electrons, which it does. It steals 2 electrons from magnesium. After it's done stealing the electrons, 2 of them, the iron goes from a charge of +2 to being neutral. The 2 electrons cancel out the 2 positive charges. In the meantime, magnesium, which started off neutral, has now lost two negative charges, and so it finishes up with a charge of +2. So the magnesium here excuse me, has been oxidized by the iron. So the magnesium has reduced the charge level of iron from 2 to 0. So magnesium is a reducing agent, okay? While as the iron has stolen 2 electrons away from the magnesium, so it is said to be the oxidizing agent. Magnesium was oxidized, its charge state went up, iron went from +2 to 0, so its charge state was reduced, and iron is also said to have been reduced. So we can rank these in terms of how good things are at stealing electrons, starting from calcium, which magnesium was able to steal from, and then magnesium lost its electrons to iron, so iron is better at stealing than magnesium, and magnesium is better at stealing than calcium. So we can conclude from that iron is better at stealing than calcium too. So from weakest to strongest here, we go calcium, magnesium, iron. So if you're trying to accomplish the goals of this lab, which remember are to rank these 4 metals from weakest to strongest oxidizing agent, we basically need to have a way of figuring out which is stronger out of 2 of them. Is copper stronger than lead, or is lead stronger than copper? So the way that we go about doing this is creating a situation where 2 potential reactions can occur. So for example, if you look here, you'll see that we have Sn, tin, reacting with nickel. And the first reaction has tin neutral and nickel +2. And the second reaction has tin +2 and nickel is neutral. Now only one of these reactions can actually happen. And depending upon which one actually occurs, we should be able to identify which one of them is better at oxidizing the other. So here in this reaction, nickel is stealing electrons from tin and winding up neutral. So in the top reaction, nickel is doing the oxidizing. On the other hand, in the bottom reaction, tin is going to be stealing electrons from nickel so that it winds up going from +2 to neutral. Okay, so here tin would be the oxidizing element. Now the trick is only one of these 2 reactions will actually happen, and depending upon which one does occur, we can tell whether tin or nickel is the stronger oxidizing agent. Okay, so how does this actually show up in the laboratory? Well, let's go take a look at the simulation that you're going to be using in order to actually perform this lab. All right, so we have the same basic types of materials that we've had before. We're really going to be focusing in here on working with solid powdered metals, and you can see there are 5 of them. We've got silver, copper, zinc, lead, and magnesium. And for what I'm going to do, I'm just going to use some silver, okay? And the other thing I'm going to use here is, I think I'm going to pick out magnesium, all right? And what I'm going to look at is, what process would I use if I wanted to try to compare silver and magnesium to see which one is the stronger oxidizing agent? In other words, which one is better at stealing electrons? Okay, so what I'm going to do is, now that I've got some solid powdered metals, I'm going to go to solutions. And what I'm going to do is I'm going to pick out solutions that I can partner up with each of these powdered metals. So what I'm going to do first of all is I'm going to find a solution that has positive magnesium ions in it. Okay, so here's one. All right. And so I'm going to partner that up with the silver. Okay, so these two guys are going to work together, and that's going to be one possible reaction. And then I'm also going to get a solution that has some silver in it. Okay, and so let's see, here's a silver solution. All right, so the trick is, on the left-hand side, we've got neutral metal and positive magnesium ions, so neutral silver and positive magnesium. And then over here we've got neutral magnesium and positive silver. And again, those are very much like the two reactions that we're looking at right here. So in one we've got neutral tin and positive nickel, and the other we've got positive tin and neutral nickel. And only one of the reactions, again, can actually happen. Okay, so we've got neutral metal, positive ion, neutral metal, positive ion on the left-hand side waiting to react. So we need to create a space for them to actually react. So let's go find ourselves some glassware. No, not that glassware. All right, I'm going to just grab a couple of beakers. One for each of the two. And so basically when you go to do this test, what you're going to do is take a certain amount of each of the two elements, and you want to make sure you have enough that you're going to react with everything that's there. So we have a 0.1 molar solution of 50 milliliters, so that is a 20th of a liter and a 10th of a mole. So we're talking about something on the order of a 200th of a mole. So if we have, maybe 10 or 20 grams, we should be way over what we need. So I'm just going to drop about 20 grams in here just to have excess metal for this reaction. All right. And now what I'm going to do is I'm going to add some of the solution here. So I'm just going to add maybe 20 milliliters. Okay. And so that's one of the two possible reactions. I'm going to do the same thing over here. I'm going to put in 20 grams of powdered magnesium, and I'm going to drop in 20 milliliters of solution. All right, and so now we have two solutions. And what you have to figure out, and this is part of the problem-solving aspect of the lab, is how can you tell if a reaction occurred? So you're going to have to use information that shows up over here in the solution inspector. And it gives you information about what's in the solution, and it also gives you information about what is in the beaker. So you can check one beaker and look at the information that's provided, and the other beaker and look at the information that's provided. And by evaluating and analyzing that, you can come up with evidence for which of these two reactions actually occurred. And what that will allow you to do is decide whether or not it was one of the elements that was stealing electrons or the other element that was stealing electrons. Now, the example that I gave you here, I chose to use a combination that doesn't show up in the lab. You're interested, remember, in magnesium, lead, zinc, and copper. Silver doesn't play a role in this. So you're going to be doing other tests. But essentially, you're going to need to do what we're looking at here. We've got silver and magnesium, silver powdered metal, magnesium in solution, magnesium powdered metal, and silver in solution. We add them together into a beaker, and then we look at what the solution inspector tells us for each one to try to decide, did a reaction occur in this situation? Okay? So That's the basic process that you're going to be using in order to complete the lab.